This video discusses a particular type of matrix called an augmented matrix. An augmented matrix is used in representing a system of linear equations. Here we can see a system of linear equations, and then on the right I've written the corresponding augmented matrix. In the augmented matrix, each row represents one of the equations in our system of equations. And what we've entered into our augmented matrix are only the constants and the coefficients of each term. Our first column are the coefficients of all the x terms. Our second column is the coefficients of all of our y terms. The third column, the coefficients of all the z terms. The vertical line is like the equal sign, and then to the right of the vertical line in that fourth column, we have all of the constants. So our first equation is paired up with the first row in our augmented matrix. So we have 1x minus 1y plus 1z equals 2. The second equation lines up with the second row. That's 2x plus 2y minus 3z's equal negative 3. And then our third equation with our third row. 1x plus 1y plus 1z equals 6. We need to practice going from systems of equations to augmented matrices and back. So let's write each system as an augmented matrix. Since there are 3 equations, our augmented matrix is going to have 3 rows to it. You'll notice in this example, the variables are x1, x sub 2, and x sub 3. These are distinct variables, so sometimes this notation is used instead of using different variables like x, y, and z. My augmented matrix is going to have 3 rows to it. The first column is going to have all the coefficients for x sub 1. The second column, all the coefficients of x sub 2. The third column, all the coefficients for x sub 3. And then on the right of our vertical line, we'll have our constants. So I'm going to go right across with our first equation. That's 1x1 minus 1x2 plus 2x3 equals 3. Now our second row, it's 1x1 plus 1x2 minus 3x3 is equal to negative 5. And lastly, we have 1x1 minus 1x2 plus 1x3 is equal to 2. Let's try the next one. Again, we have 3 equations, so I know that my augmented matrix is going to have 3 rows to it. My variables this time are x, y, and z. So the first column will be the coefficients of x, the second the coefficients of y, the third the coefficients of z. And we're just going to go straight across with our first equation. That's 3x minus 2y plus 4z is equal to 5. Now, if you'll notice in our second equation, y minus 3z equals negative 2, there is no x term. We are going to put a placeholder of 0 into our augmented matrix for any term that isn't there. So we have 0x, 1y, minus 3z, and then equal to negative 2. You should never have any blanks in a matrix. So if something isn't there, we put in a placeholder of 0. In our third equation, you'll notice that there is no y term. So we'll be using a placeholder of 0 in our third row, the second column for the y. So 7x, 0y, minus 1z equals 1. In our next 2 examples, we're going to go the opposite direction. Here I've given you the augmented matrix, and I want you to write a system of equations that goes with it. You want to start by choosing which variables you're going to use. I think I'm going to use x, y, and z. I know that I need 3 variables because I have 3 columns to the left of my vertical line. My first column will be the coefficients on x, the second the coefficients on y, and the third the coefficients on z. And each row will give me an equation. That's going to be negative 1x plus 1y plus 1z is equal to 7. Now, of course, I don't have to write the ones, but I'm just writing them to emphasize where the numbers are going from our augmented matrix to our equations. Our second equation, that'll be 1x minus 1y minus 1z equals 2. In our third row, we see that we do not have an x term, right? 0x, so we don't need to list it. I mean, if you really wanted to, I guess you could, but later it's going to be more confusing to have it than not. So we have no x term. That's negative 1y plus 1z equals negative 1. And that's our system of equations. Let's take a look at our next example. Because I have 4 columns to the left of the vertical line, that tells me that I need 4 variables. And you can choose whatever variables you like, A, B, C, D. We could use x1, x2, x3, x4. I think that's the notation I'll use. W, X, Y, Z also works. There's only 2 rows, so that means we only have 2 equations to write. Our first equation, that'll be 1x1 plus 2x2. We don't have any x3s, and then plus 2x4s equals 3. Our second equation, we don't have any x1s, no x2s. We have 1x3 plus 3x4 equal to 7. And that's our system of equations.